Alrighty, so this video is the final exam review for the course. So just want to explain what you can expect from the final exam. It's basically just like all the other exams. You can expect it to look similar, same kind of formatting. It'll be posted to Canvas in the morning on your exam day, which I believe is Thursday, May 6th. So I'll post it in the morning time, and you'll have the full day to work on it. So I'm not just going to make you do it only during the 2 hours scheduled, but I'll give you the full day. But that also means I will not be accepting any late submissions. You must submit the test to me by 11:59 p.m. So the best thing to do is, of course, download it as soon as you can and work through it, and try to submit it as early as possible. That way, if Canvas isn't accepting it, you could email me right then and there, say, look, Canvas isn't accepting it, here's a copy of it, and we'll try to figure out what's going on. But I don't want to see someone wait till Friday and say, oh, I tried to submit it yesterday, but it didn't happen, so here it is now the next day. No, that's a late submission. You know you have the full day on Thursday, so best thing to do is work it early and try to submit it early. That way there will be no technical issues, no blackouts, no internet issues, anything like that. Everybody has a cell phone with their cell service on it. You have the ability to take the pictures and email me the pictures, even if there's no Wi-Fi there on campus or anything like that. So there's no excuses. Now, other than that, you can expect the test to be about twice as long as a regular test. If a regular test is about 50 minutes, this is about a 2-hour test. It is cumulative, so it'll cover all of the topics we've gone over through the semester, and that's basically what I want to do here, is just go back over the topics we've covered to just refresh your memory what to expect. So, first thing we had was Ohm's Law. And with Ohm's Law, we had, series versus parallel resistors. The big one, V equals IR. And so these were the questions where you'd have a circuit, and there's a little table of values you have to fill out. And so for each one of these resistors, tell me what's the current and what's the voltage drop by that resistor. And so you'd fill out the table. Then we had some more fancy techniques, which were like loop analysis and nodal analysis. We still had the same basic types of questions. You're given a circuit, and I want you to tell me all you can about the resistors, but the way you're solving the circuit is different. You may be asked to do loop analysis on the circuit, in which, for each loop of the circuit, you assume there's a current flowing through that circuit or in that loop, and you build out a series of equations for each loop. A series of equations in terms of voltage, and the voltage is written as I times R, basically. Or nodal analysis. That was the other version, where each node in your circuit has wires coming in and out of it, and for each one of those wires coming in and out of a node, there's a current. And so you would have all the currents coming in minus all the currents going out is equal to 0 for a particular node. And then you'd set up a series of equations for each node. And then again, you'd solve those equations to calculate whatever it is the question's asking. So those are the two big, more advanced techniques. And then we had kind of the other techniques which you still have to use either loop analysis or nodal analysis or regular old Ohm's Law, but you may have to do something at the beginning of the circuit to help make the circuit able to be solved. And for instance, we had the voltage divider, or current divider. Those were just kind of little fancy math techniques or little tricks to solve for the total voltage or the total current that's split among resistors, so divider. And the other fancy technique was called the superposition principle. And with this one, you had, a circuit that maybe had multiple sources in it. Here's something like this, I guess. And maybe you want to know what's the current flowing here. And you can see this has two sources, a voltage source and a current source. And what the superposition principle says is you could break this one problem up into two smaller problems. One, which has the voltage source and the current source becomes a break. So it's like you cut the circuit off where the current source was, and so now you just have this, a voltage source with your R1 and your R2, and you calculate what's the current flowing over there. And then the second one would be, now you keep the current source, and of course the resistors and all, but now your voltage source turns into a short, just a wire. And again, so R1, R2, and I source. And so you would solve this problem, and then you would solve this problem, and you'd add the two answers together to get the answer for the total circuit. Okay? So just a different technique. Obviously, you could use something else. Maybe you want to use nodal analysis or loop analysis or stuff. But if you're asked specifically, then you have to follow the rules. So if you're asked to do superposition principle, then you'd use that technique. And of course, as I said, the major rules for superposition principle are when you keep, let's say you're keeping one of the sources, all the other sources go away, all voltage sources becomes short, and all current sources becomes breaks. Okay, so no matter how many sources are in there, maybe you have 5 sources. So that means you're going to break the problem into 5 different pieces. Take the first source, all the other sources turn into whatever they're supposed to. Finish that one. Go to the next source. Now all the other ones go into their pieces, and now you only have that one source for number 2. Get the answer for that, and so on. Once you get all 5 answers, you put all 5 answers together. But that's it. These are your topics. Right here. So you know what to expect. The best way to study, as is true of all my courses for final exams, is first thing, work on the exams we've had. Work those problems. Make sure you understand how to do the exam problems, because I obviously felt they were important enough to test you on. So on a final exam, those are still similar to the types of problems I think would be important. So work on those. Then, of course, look at homework problems or the practice problems that are posted on Canvas. Those are there available to you. The solutions are there. So if there's a particular topic, one of these topics that you're not sure of or you're kind of uncomfortable with, then look at those particular problems under the practice sets. Look at the solutions, see how I'm working them, and see if you can reproduce them. At the end of the day, if you could work the problems that I've posted on Canvas or have been on the tests, those are similar to what you're going to see on the final exam. So you know what to expect. You're not going to get any surprises. It's just a matter of practicing enough so that when you do get the test, you're comfortable with the topics. Anyway, that's it for the final exam review. If you have any questions about any of these things, obviously you're always welcome to email me. But definitely practice. Look up the practice problems that are on Canvas so you can do the best job you can on this final exam. Again, it will be Thursday, May 6th. I'm posting it early in the morning. So you'll have the full day to work on it if you need it. You won't need the full day. It shouldn't take you that long. But in case you have weird scheduling issues or whatever, you have the full day. But no later than 11:59 p.m. I cannot accept late submissions of final exams. So submit as early as you can to avoid any technical issues. Alrighty, well, until next time.